Welcome. So what I want to do is show you how to graph y equals negative x squared plus 1. And we're going to use this by using a table of values. So what we've gone through again is let's create an x and y axis here. All right. Now remember, when we're graphing a quadratic that it's in the form of y equals ax squared plus c, we know that our axis of symmetry again is going to be 0. However, we're going to have some effects on our graph when we have it in this form, when our a here is -1 and c is 1. And what I want to use is use a table, but then we'll be able to analyze and see what's happening to the graph. OK, so we need to create a table of values. And remember, what we stated is when we're using when we're graphing a quadratic that's in this format, we know that our axis of symmetry is at 0. And axis of symmetry is very important when graphing quadratics, because that's going to be the point where our graph, or our parabola, the name of a quadratic graph, is going to be symmetrical about. So therefore, we're going to want to choose 2 points to the left and 2 points to the right. Now, I'm not going to go super crazy on this. Since we have a coefficient here, let's just pick -2 and -4. Let's do -1 and -2. And then let's do +1 and +2. Now remember, it does not matter which points you choose as long as you're choosing 2 to the left and 2 to the right. However, a quadratic, since it's being squared, if I had to pick like -5 and -10, well, that's going to be numbers 25 and 100 would be my output. That is going to get very, very large very quickly. So we want to choose points that are going to be very close to our axis of symmetry. Now, to find our x coordinates, we chose those values to the left and to the right of the axis of symmetry. Now we need to figure out what the y values will be in agreement to these x coordinates. Because remember, every point on a quadratic has an x and a y coordinate. So if I say the x coordinate is at -2, what is going to be the y coordinate? So to do that again, all I simply do is now substitute in a -2 in for x squared. Now notice my use of parentheses. The use of parentheses is very, very important here, because I'm not squaring a +2. I'm squaring a -2. So a -2 squared is 4. 4 times -1 is now -4, plus 1 is -3. Y equals negative times -1 squared plus 1. -1 squared is +1. +1 times -1 is -1. Plus 1 is 0. Then I do y equals negative times 0 squared plus 1. Well, 0 squared is 0. 0 times negative is 0. That becomes a 1. And then the important thing to know about my axis of symmetry is my points are going to be now exactly the same. But let's just go ahead and check it out again, and just to kind of verify this. 1 squared is 1 times -1 is -1. That gives me 0, which is the exact same for -1. And then I have y equals negative times 2 squared plus 1. That equals +4 times -1 is -4 plus 1 is -3. Now I'm going to plot the points. So I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. All right, so I go over to -2 down to -1. Over to -1 at 0. 0, 1, +1, 0, +2, -1. All right, so now I'm going to try to do my best here. And I didn't really graph the best one up there. But hopefully you can see this takes a parabola shape, which we call like a U-shaped graph. But just take a look notice that when we looked at our parent function, remember the vertex was at 0, 0. Well, now that I've added this +1, my graph has been shifted up. And also my a is negative, which now has my graph opening downward. And that's going to become very important later in the class. But let's just go and look at our vertex. Remember, a vertex is the maximum or minimum of the graph. And by looking at this graph, we can say the vertex occurs at the point 0, 1. And notice that the x coordinate of the vertex is the same thing as the x coordinate of the axis of symmetry, right? Because remember, the axis of symmetry is this dotted line, which I said was at 0. And you can see that that evenly cuts our parabola in half. Then we look at our axis of symmetry. Now remember, that axis of symmetry, that red line, is a line. So our vertex is a point. Our axis of symmetry is a line, which is at x equals 0. And then we have x-intercepts. X-intercepts are where the graph crosses the x-axis. So here's our x-axis. Here's our y-axis. And we can see it actually crosses our x-axis at 2 different points. crosses at -1 and +1. So I'm going to label both of those points as my x-intercepts, and then my y-intercept. There's only one of them, because the graph only crosses the y-axis at 0, 1. So there you go, ladies and gentlemen. That is how you graph y equals -x² + 1. Thank you.